So let's take a look at an example now where constructors and destructors are used. First of all, the person class. Here we have the two variables that we've seen in the partial example, and we also have a third variable that is going to be a pointer to a person object, and we're calling it buddy. The variables will typically have set and get methods. So get name, set name, get address, set address, get buddy, set buddy. And there's also a couple of constructor methods. Let's look at the default constructor first. We'll put in some default values for name and address as we saw previously. And buddy, because it is a pointer to a person object, we'll give it the initial value of null. N-U-L-L in uppercase letters. In the case of the other constructor method, the overloaded constructor, we'll use the two parameters n and addr for the values for name and address, and we're still setting buddy to be equal to null. Get name is as you would expect it to be. It simply returns the value of name. Set name is as you would expect. Take the parameter and store it in the variable name. Similarly for get address and set address. Let's take a look at get buddy. Get buddy is going to return the pointer to the buddy object, which is of type person. And because buddy has been declared as a pointer to a person, then this method is going to return a pointer to a person. So we've got to make sure that we put the asterisk in front of the method name too. So this method, getBuddy, is going to return a pointer to a person. And it can simply return buddy because buddy is of the correct type. With the setBuddy method, because buddy is a pointer, that means the parameter that we need must also be a pointer. So P, the parameter, is a pointer to a person object. And then we can make buddy equal to P. So those are the constructors and the various other methods. Let's take a look at the main method that uses them. First of all, in this class, we need to include the person.cpp file so that the class person is available to this method. And then we can declare person P, which is a variable declared on the stack and is using the default constructor. P1 is also declared on the stack and we're using the overloaded constructor. The third object that we're creating is a pointer to a person object, and therefore we're creating a new person object on the heap using the overloaded constructor. And the fourth person object is also a pointer, so we're creating a new person on the heap. Then I've created a couple of other person objects, B1 and B2 for the two buddies, also on the heap. And if we just take a moment to review how we call the methods, because these are on the stack, we can just use the dot notation, p.getName, p.getAddress. Whereas because P2 is pointing at an object on the heap, then we have to use the arrow notation to call the method. In other words, P2 is a pointer, follow the pointer to that object and then call the getName method. For P1, which is an object on the stack, we call setBuddy by using the dot notation, and for P2, which is an object on the heap, we call setBuddy by using the arrow notation. And then when we output the details of P1 and P2, both of whom have got buddies, we'll see that these values should be output as we expect them to be. So P1 will have buddy as the buddy, and P2 will have bud as the buddy. Let's just run that to see the effect. So immediately after creating person P, we output the details of person P, which used the default constructor. After creating person 1, we output the details of person 1, which used the overloaded constructor. Likewise for person 2. Then we set the buddy for P1 and for P2 and output the details again of P1 along with buddy and P2 along with buddy. So we can see that the pointer was correctly set up because for P1 we're calling getBuddy, and then from there, because it's an object on the heap, we're calling the getName method using the arrow notation. And we're getting all the correct information coming out. Now let's take a look at deletion. Remember, P is a variable on the stack. Let's attempt to delete that object by using the delete operator. So we're outputting a message to say I'm about to delete P, then we delete P, then report that we have deleted P. Notice that we get this runtime error and we'll abort the program, and as we see what's happened, we output the message about to delete P, but then the very next statement, which was the attempt to delete that object on the stack, that failed and gave us the runtime error. You cannot use delete to delete variables that are on the stack. You can only use delete for deleting variables that are on the heap. On the other hand, because P2 is on the heap, we ought to be able to delete P2, likewise delete P3, and then we'll output the message end of program. And that's exactly what happens. Get the message deleting P2, deleting P3, and then end of program. So those objects have now been deleted. So what about the destructor methods? Let's take a look at how they would operate. In the person class, we can put in a destructor method by declaring the method as we would normally. Remember the tilde character in front of the method name, which makes it a destructor. Output a message here to say the destructor has been called for, and then put the person name. That way we know that the method has been called. For the moment, I'm just going to comment out that bit of code so that we can just get the message to say the destructor has been called. And now let's clean the solution because we've changed that class and run the program again. This time we get a bit more information which shows us when the destructor method is called. We have the message from the main method saying deleting P2, and then the next statement is a call to delete P2, which then calls the destructor method for P2. Remember, P2 is Dave, so the destructor has now been called for Dave. So the destructor is called immediately when delete is called. Likewise for P3, and then end of program. So we've reached the end of the main method. Now remember, in that main method we declared two variables on the stack, P and P1. The default constructor was called on P, which was declared first, and then the overloaded constructor was called for P1, which was declared second. What happens is that when the main method is removed from the stack, those variables will be deleted. The runtime environment does that for us. And the destructor method will be called again, this time in reverse order from declaration. So the destructor was called first for Graham, and then the destructor was called for P, and that then finishes the execution of the program. We have to understand that the destructor method, if we provide it, will be called for every single object that exists. The ones that are declared on the stack will automatically be deleted when that method is removed from the stack. But for the objects that we create on the heap, we have to call the destructor for it by calling the delete operator. Remember that we cannot delete objects that have already been deleted. What if, when this person object was created, it was never given a buddy? Well, in that case, we don't want to try to delete buddy because buddy doesn't exist. Hence the if statement in the destructor. So if buddy is not equal to null, that means there is a buddy object and therefore we should delete it. So a message to say about to delete buddy, then delete buddy, and then set buddy equal to null. This is not required, but is good practice. Because remember, once you've deleted an object, you then should not be trying to access it. And just as a way of indicating, actually, this has now been deleted, it's probably a good idea to set that pointer to null so that it is no longer pointing at an area of memory that you've just deleted. All right, let's see the effect of this when we run the program. Now remember, Graham is an object on the stack. And one of the statements that we executed was to set B1, who is buddy, as the buddy for Graham. Now, after the main method has finished executing, Graham is going to be deleted. Therefore, the constructor method for it will be called. And now that we've got that if statement in there, we're also going to delete from the heap the buddy object. The object P which does not have a body, because of the if statement, will then not attempt to delete the body because the body is still null. Let's try something slightly different. What if B2 was not going to be an object on the heap, but an object on the stack? Here we are. B2 is now declared as a person object on the stack. Therefore, when we set body, we need to provide a pointer to that object. So instead of B2, we need the address of B2. So now we've got a pointer to the body that is an object on the stack. So P2, which is on the heap, is pointing at an object on the stack. What will happen when we attempt to delete P2? Well, what will happen is that the destructor method will be called for P2, and that destructor method will then attempt to delete the body, which is an object on the stack. And because it's an object on the stack, we can't delete it. So we'd expect the program to abort. And that's exactly what happens. We're deleting P2. The destructor has been called for Dave, about to delete Dave's body. The destructor has been called for Bud, and that causes the problem. Okay, we're trying to delete an object that is on the stack. Not allowed. And so the program aborts. And so really the rule of thumb is, if you're going to put an object on the heap, then make sure that every object that it points at is also on the heap. That way, when you delete things, you're not going to fall foul of this problem of trying to delete objects that are actually on the stack. So we never delete objects on the stack. They're done automatically when the method finishes.